These problems are from section 12.1, which deals with compound interest future value. So it answers the question, or these problems answer the question, if I invest or borrow a certain amount of money today, which they're going to tell me, what will it be worth in the future? So you want to use a future value table to answer these questions. The first one is if I invest for 12 years an amount of $15,000, so that's the present value, at 3% compounded annually, what amount will I end up with and what interest will that represent? First thing I need to do is figure out the number of periods. Number of periods is always the years times how many times you compound it per year. So I have 12 years annually. That would be 12 times 1, or 12 periods. And then I want to find out the rate per period, and I always take that annual rate and divide it by the number of compoundings. And since this is annual, there's one compounding per year, so I'll keep that 3%. And then I need to go to the future value table. That's in your textbook on page 297. And we have 12 periods at 3%. So we go down the column here to 12 and over under 3%, and we find the table factor is 1.4258 here, and we have 1.4258, and to get the total amount that I'll have after 12 years, I'm going to multiply that by 15,000. So your total amount after the 12 years will be $21,387. And we invested $15,000, so I would need to subtract, this is your amount, so that's what goes in that column, but for the interest, I need to subtract off the original $15,000 and find out that we earned $6,387 in interest. This next problem is 6 months quarterly. So 6 months would be half a year. To find the periods, it's always in terms of how many years. So if it's a fraction of a year, 6 months would be half a year. Multiplied by 4 compoundings per year gives you, you're going to just have 2 compounding periods for this money. The interest rate is 8% divided by 4 compoundings per year because it's quarterly. So the interest rate per period is 2%. So then we go back to the table and we have 2 periods and 2%. So go back to your future value table. Look up 2 periods and 2%. So your factor is 1.0404. So our table factor is 1.0404, which we will multiply by our principal, $10,000 here. And we find out that we'll end up with, at the end of 6 months, a total of $10,404. And since we originally invested $10,000, if we subtract that from the amount that we end up with, it'll give us the interest. So our interest is $404. And let's do one more of these. 3 years. Compounded semi-annually, so semi-annually would be twice a year, so we've got 3 years times 2 compoundings per year gives us 6 compounding periods. And 12% semi-annually, so we divide by 2, would give us 6% per period. So we go back to our table, 6 periods and 6%. So find 6 in the period column and go over under 6%. 1.4185. Multiply that by your principal that you're investing, which in this problem was $2,000, and you'll find out that at the end of 3 years you will have $2,837. So that'll be your total amount after 3 years, and if you want to know the interest, then subtract the principal from that amount, and our interest is $837. Now this next problem wants you to calculate the effective rate, which they call APY, of interest for 1 year. The reason we do effective rates with compound interest is that with compound interest, you're earning interest on interest. So in a problem like this one up here where it said you had 3% annual interest, you actually will be earning a little more than 3% because you're going to earn interest on the interest. So every year the principal is going to be a little bit different. So there are 2 ways to work this problem. One of them is to figure out how much interest there would be in a year. Well, if we're compounding quarterly, that would be 4 periods in 1 year. And we would divide the 12 by 4 to find out that each period would be at 3%. And then we would go to the table and look up 4 periods at 3%. So 4 periods at 3% is 1.1255. Now, it turns out that this decimal 0.1255 is actually the APY. So if we change that to a percent, we can get 12.55%, and we're done. That is the APY. But your book also shows you how to calculate this using the interest divided by the principal. So if we continued on with that method, if you didn't happen to know that you could read the APY right off of the table, we take our table value, multiply it by the 15,500, and find out that that is $17,445.25. That would be the total amount, so the interest would be, subtract our 15,500, and that is a 4. It looks a little bit like a 9. And we find out that the interest earned here was $1,945.25. So the formula in the book says take the interest, divide it by the principal, which was 15,500, and that will give you APY. And indeed, it does give you that same 0.1255, which we can turn into a decimal, and we'll have the 12.55% that way. Either of those is a perfectly legitimate way to work that problem. And one last problem. Lynn Alley, owner of a local Subway shop, loaned $40,000 to Pete Hall to help him open a Subway franchise. Pete plans to repay Lynn at the end of 8 years, 6% interest compounded semi-annually. So 8 years semi-annually is going to be 16 interest periods. 6% semi-annually comes out to 3% per period. So if we go to the table and look up 16 periods and 3%, you will find that that factor from the table is 6047, and times the 40,000 that he borrowed. And you will find out in the end he's going to have to pay back $64,188.